to introduce you to something I like to call lobotomizing the NES. Basically, it's really not hacking, it's more of an exploration. Really, you're not doing anything super useful. Basically what you're doing is you're going to run an emulator on your PC or console. Now, I don't want to hear any shit about emulation being illegal. I don't want to hear it. I don't care. The NES, the Nintendo Entertainment System, is damn near as old as I am. And if Nintendo wants to still make money off the NES, bitch to someone else. I really don't care. Don't want to hear it. So, and I also don't want to hear, Fox, where do I get ROMs? Fox, where do I get emulators? Use Google. I'm not going to help you. Okay, default disclaimer, blah, 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 blah. Emulation could be a crime, blah, blah, blah. Emulation could be copyright infringement, blah, blah, blah. DMCA can blow me, blah, blah, blah. Don't steal stuff, blah, blah, blah. Peer-to-peer is from Satan, blah, blah, blah. Newsgroups rock. BitTorrent blows. So, anyway, you're going to fire up a ROM, or a cartridge image of the game on your computer, and using an emulator, such as NES 10 or FCE for Windows. I'm not into the emulation for Mac or Linux. Just Google it. There are emulators. What we're going to do is we're going to poke around the memory addresses, essentially creating cheat codes. But those cheat codes will then allow us to explore further into the memory and do interesting things. Some of the interesting things is, in Duck Hunt, when you reach level 99 of the game, as soon as you reach level 100, there's a buffer overflow, and weird shit happens. There are just weird things you can do in Super Mario Bros. 3. There are whole levels that have been unused and whole worlds that just were left in the game but unfinished. You can go in and access them. So this is why I call it lobotomizing the NES. You're going into the memory with a hot red poker, and you're poking around, seeing what does what and how the game's put together. You have to understand different computer number systems. In decimal, it's base 10, meaning we have 10 digits, 0 to 9. 0 is a digit. Now, 0 is a digit because let's say if we have 99, we have 2 places. However, if we have 109, we have nothing to take up the 0 before, the 0 that's in between 1 and 9. In the computer systems, we have binary, where there's only 1 and 0. And in binary, we don't have digits, we have bits. Just a 1 or a 0. Now, depending on how many bits you can have will determine how large you can count up to. If you have 1 bit, you can only count up to 1. If you have 2 bits, you can count up to 3. And so on and so on. I'll give a little tutorial. If you're interested in this, I'll have a tutorial on the show notes on binary number systems, and there's also hex number system. It's base 16. It doesn't go from 0 to 9. It goes from 0 to 9, then A to F. It's a 16-digit long numbering system, base 16. I'll give tutorials about that on the show notes if you're interested. But let's get into the emulator, which I'm going to have on the PC and on my Xbox. I'll explain those reasons while we're doing our lobotomization of the NES. I fired up an NES emulator on my Xbox. The reason I plan on using this emulator for the segment primarily is because I enjoy having my hands on a controller that can start and stop the emulator as faster than I can actually think. Basically, it's just a natural reaction to stop it. You have to understand that we'll be comparing and contrasting memory values, and seconds do count when you're doing stuff with timers and whatnot. So let's select a game. We'll do Super Mario Bros., the original one for NES. We'll start up a game. One-player game. The first thing we'll hunt down is the address for time. So we'll go to our cheat codes and start the search. Basically, the emulator has just memorized every single memory address and all of their values. That way we can compare and contrast. Now, we waited 2 seconds. The time is going down pretty quick, so we go to our cheat codes. Can you continue search for less than before? Okay, we're down to 15. Okay, 2 seconds on the timer have passed on the ones counter. Continue search, less than before. We're down to 5. 2 seconds have passed by. We're going to do it again. We are down to 3. Okay, we'll add it to the list because sometimes, remember, this is pretty much hit or miss. There might be the possibility that you missed the code because you compared and contrasted incorrectly. Okay, so we have a value of decimal 64, value of decimal 47, and decimal of 5. Well, the last time I looked, the counter was at either 5 or 6. Keeping in mind, 0 is a number.
Okay? Now, the way this cheat code system is actually enabled, the way it works is, if a cheat code starts with 30, it says lock the 8-bit value of the 8-bit address at the current value. So if I enable this, it's going to lock address 07FA to a value of 5. And there we go. It's locked. So, go through our game. And it's locked at 5. Well, 4. But keeping in mind that 0 is a number. Okay, let's go to our cheat code. Start search for a new for the new code. Let's do lives. So, whoop, I'm dead. Well, apparently, it's less than before. Cheat codes, less than before. Oops, I'm dead. Okay, apparently, less than before. But notice we're not rounding these down fast enough. If you don't mind me, I'm just going to use my fast forward button in my emulator to get this going. Now, when we start a new game, notice how the value of the lives has increased. So, greater than before. We're down to 3. So, list our cheat codes. Oh, wait, you know what? It's a good idea to label these. What was this? Time ones. Oh, shit. My keyboard's not working. That sucks. All right. Fine. T-I-M-E. Okay. That's our time address. Well, this is awkward. Where are our lives? Well, maybe we didn't get them. Nope, no, here we go. Start search again. Less than before. Oh, game over. Start it up again. Greater than before. Less than before. Less than before. Okay, there's only one code left, so we'll enable this always on as this value, blah, blah, blah. Hey, look, we got 2 lives. Hey, look, we've got 2 lives. Hey, you know what? We know this is our lives, and you have to understand that this is an 8-bit system. So that means there is only possible of 255 combinations. So let's edit this to see what happens when we hit FF. Or 255. Oh, let's go die. Oh, game over. Now look at that. Isn't that weird? When you have 255 lives, the maximum value, your game is over. I wonder why that is. Alright, so we'll go to our cheat codes. Whoop, list them. Edit this so it's only 254? Yeah, 254. Alright. Game over. So apparently we're doing a buffer overflow right now. What's basically happening is you're overflowing into a piece of memory where it can't register how many lives you have. And this is just for one of the reasons why you should lobotomize your NES. Alright, so let's do AA. 170. What happens when you have 100 and... Oh, wait. I went too fast. Oh, and another buffer overflow. We just saw 2 more buffer overflows. We'll go to another one-player game real quick. Look, if you notice the lives, they're sprites. See, there's no actual fonts and text in NES. They're all sprites. So basically, you're doing a buffer overflow where the lives are greater than the maximum amount it can count, and it's overfilling the sprite table. But what's also happening is when you die, that same buffer overflow of when we did it to 255 is causing the game to be over. So, another interesting thing. Huh. Okay, we're going to go ahead and select Meyer Brothers. We're going to do some stuff with Duck Hunt. Duck Hunt for NES is one of these smaller games for NES, so it's really easy to find memory addresses. The first thing I want to find is the memory address for bullets. So, let's get started. Okay, we have one possible address, and we're going to enable it. We know the maximum value for bullets is 3, so we're going to enable that to 3 and see if it works. Yep, it works. Now we have infinite bullets. Second address I want to look for is the duck's flyaway time. So this is going to be another one of those you got to be quick on the button. Okay, we got 2 possible codes, which weren't... crap, I fucked up. There. We got 2 possible values. BA is for the bullet, so I'm gonna assume it's 4C. 31C looks like it's too far into memory, but I could be wrong. Let's see if this duck ever flies away. Nope, he doesn't fly away. So that other one, this one, 31C, could be the memory address to tell the game, make the screen pink and put the flyaway sprite on the screen. But either way, you know, this duck ain't going anywhere. So I can go ahead, no matter what, he ain't going nowhere. Now what I'm going to do is I'm going to try to find the memory address for what level we're on. Now this is going to take a little while, so I'll just continue when I've found it. With a little bit of diligent searching, I found the memory address 00C1, which is the memory value for what level you're on. Now we're gonna do a little bit of testing. We're gonna see what happens when we bring this up to level 98. Now I know for a fact that they use hex codes, keeping in mind that all of this over here is hex. This is not decimal. They use a hex value to determine what level you're on. It's up to the actual game on whether or not you use hex or if you use decimal. Now look, our round indicator says that we're on 3, but these ducks are moving way too fast for round 3. So this goes to show you that your memory address doesn't directly affect what you have on screen. Now, you could just accidentally find a memory address for the sprite that's displayed on the screen, but still not affect the actual value. Once we get past this round, it'll go up to level either 98 or 99. It'll actually update that value. So I'm going to go and fast forward through a little bit of this because I don't want the epileptics to complain. Okay, we should be going up to round... Oh wait, gotta turn that memory value off because... Actually, we gotta wait till the next... until it hits the register. Once it hits the register, we're on round 98. We're gonna go to our cheat codes, because you gotta remember, in this emulator, any code that starts with 30 says, fix this value as... this address at this value. If we made it 80, it'd say, when this value is equal to this, go to the next code. So using that, you can make some pretty interesting stuff. So we're going to turn this off because we're on level 98. I'm going to go and buzz right through this. If you notice, the round indicator is only 2-digit. I don't think the programmers ever designed to have a 3-digit level system, which is much like the Y2K bug, where clocks only had a 2-digit time code for the year, like 98, 99. But once you reach 2000, it's not 2000, it's 00. So software that says, hey, okay, you know, if the year is less than, say, 95, you know, these people owe us money and have this % interest for every value of difference. So, you know, weird shit was going on. Not only that, but we've also got memory overflows and buffer overflows. So it's going to be putting values into memory that it shouldn't be putting values into. I'll give a show notes to a very good IPTV show that had a beautiful example of what exactly a buffer overflow is. Okay, we're going over to what level now? Level 99. So, okay, so our round on the sprite and the value have both leveled out. I'll breeze through this real quick. I love that fast forward button on the emulator. Makes life so much quicker. Okay, we should go to round 100, right? Round 0. What happened? Hey, what the hell's going on? Hey, look at that, an awkward buffer overflow. The game just went all highball apeshit. It wasn't designed to go to round 100. So for the round, we're on round 00 in memory, and that 1 from the hundreds place spilled over to another contents. So if you were a diligent Duck Hunt player and you actually sat through all day playing 100 rounds of Duck Hunt, this is what you'd have to look forward to. But with just a little bit of NES lobotomizing, just poking around the memory address, we've got there faster, and we aren't as disappointed.